Welcome to radar system course. Today we see a MTI radar. So we have seen yesterday that the representation of a equal pulse train at RF or a IF portion of the receiver. So means we are receiving because we are sending the train of a pulse for a shorter duration because it is about a on-off modulator we are using in a MTI radar, and then that train of pulse we are receiving as a echo. So here these are nothing but a train of pulse we are receiving, okay, because these are it is just like a on a modulator we have seen earlier. Now for this particular train of pulses we supposed to find out uh, this one. These are nothing but what a echo, okay. So this one is about nothing but a echo what we are receiving, okay. This is nothing but a echo. Now we are receiving this at a receiver, or you can say that at a IF of your that a MTI radar. Now we need to see these are the pulses on the display, okay. So means whichever the signal we have received, that signal is to be seen on the display. So what will be the signal we will get on the display? That signal consists of what? A video pulses, okay. These are nothing but a pulse train, similar pulse train that continuous waveform we are sending, that is transmitting. At a receiving we are getting this, these are the train of a pulses, and the train of a pulses has the duration is about a tau here. And we say earlier, so we have to talk about that if fd is greater than then a tau here, or fd is less than 1 by 2. So what happened? Okay, so now based on this we supposed to identify that for fd is greater than 1 by tau or fd is less than 1 by 2. So what signal we supposed to be detected, or that is to be displayed on the a receiver, okay, display device. So generally display devices display the portion of the this train pulse as a video pulse, okay. And that video pulse we are detecting after that particular phase detector there, okay. So we will see that these are nothing but the video pulse we are detecting, and that video pulses have a phase difference here. These are nothing but a, we supposed to say that these are supposed to be a video pulse now, okay. So these are nothing but the video pulse of, okay. So like we are supposed to get this video pulse here, but video pulse we are getting when we have that fd is greater than 1 by 2. Then video pulse, okay. So we are getting that at fd when it will be less than the 1 by 2. And now that video pulse we are detecting on the detector, so in which we have the fd is less than the 1 by 2, that is your Doppler frequency. Now this occur whenever we have a, but you can say that a surveillance radar, and for the surveillance radar there may be a variation in the fd, okay. That is about what we can say plus or minus. So in that case fd may be greater than, fd is to be greater than 1 by 2, or fd is to be less than 1 by 2, okay. That we are saying. So earlier what we are saying, if we have a pulse duration, okay, that is we can say that the for a single pulse it is about a 2 of a duration we require. So in that case, to detect the pulse, to detect the Doppler frequency within that particular pulse, so in that case fd is to be greater than 1 by 2, okay. If we supposed to be detect the a pulse within that single pulse, then FD is to be greater than 1 by 2. Now, so generally this particular condition to detect the pulse within, detect the Doppler frequency within the given particular pulse is not possible. But we need to detect that a moving target. So in a surveillance radar, it's not necessary that it is to be detected within a particular pulse. So that's why we can say that a Doppler frequency can be smaller than that 1 by 2. So that we are able to detect that a FD there. Okay. So it, for a detection, it's not necessary it is to be FD is to be greater than 1 by 2. Okay, so even we will get that if FD is less than the 1 by 2, so we are able to detect the uh, detect that target. Okay, that is nothing but a air surveillance device. So we need to detect, even if that FD is very smaller than that particular toy there, so we are able to detect that a that particular radar. Okay, that was that target. Okay, so just like a aircraft, or we can say that a surveillance devices, that surveillance radar, they are able to detect the this aircraft there. Okay, so now, so for the given particular condition, so what will be the your pulse there? Okay, when we have FD is less than the 1 by 2. So in that case, your pulse will be what? It is just like a, we have a train of a pulse. Okay, so in that case, it is just like if it is to identify that you have for the given condition FD is less than 1 by pulse. So in that case, we need to detect that using the pulse repetition frequency, and we need to sample given particular video signal for a given particular pulse repetition frequency. So we will get the a signal here. Likewise, okay, suppose we say that this one is about train of pulse we supposed to be transmitting now. Okay, so this one we are getting. Okay, so this one. So what we can say here? We have this one. We say that this one is about your is a signal. Okay, so this one is about your. Okay, so likewise. Okay, so this way we supposed to get the just like this one. Okay, so there about the train of pulse we are getting. So in the condition is that we have this FD is to be very small that whatever the 1 by 2 here. Okay, so that is about the situation. Now we can say that if there is a changes in the frequency of echo signal, okay, so in that case, due to the Doppler effect, so we are able to detect the given particular pulse. But what we exactly needed at the receiver, we need only a single pulse can be sufficient to detect the there will be a target. Okay, so we need to use, so what will be the whatever the signal we are display for the given particular echo signal. So that signal we are getting on the display devices, it consists of a video pulse of what? A positive positive pulse and a negative pulse. Okay. So now we will proceed here. So that is about what will be the pulse video signals we are getting. Okay. So for a moving target, so we are detecting, okay, for a given particular moving target, we are able to detect the somehow this particular kind of a signal now. So I say that now this is about our signal we are getting, we are detecting. Okay, now this is about our signal. Now for a given particular this one is displayed on the generally on the display devices. Okay, so we are getting this one. Now from this you can see that these are nothing but your moving targets. Okay, these are nothing but a moving target. Generally that is, your display devices will display this type of waveform, but actually this one is nothing but these peaks. Okay, these peaks are nothing but your a target. Now we need to detect whether this, and these are the peaks here right now. What we are saying, these are nothing but the peaks, and these peaks are nothing but what, a signal we are getting from the cutter, or there may be some stationary target, and that stationary target we are getting some signal. Okay, because we are transmitting the signal in a space, even if some stationary objects are present within a given particular range, so in that case we are getting some peaks there. So our aim is about to remove these particular peaks, and exactly what we are expecting, we are expecting this particular signal. Okay, that is to be expected. Okay, so that's why we supposed to know that for a given particular display here. Okay, so these are the, for this particular display only this particular pulses is to be detected by our a display device. Okay, so now what will be the exactly, okay, moving target. So now which particular peak is supposed to be considered as a moving target now. Okay, so likewise, so what we supposed to find out, so from this which one is our original target now. So in that case we supposed to use a delay device, or we can say that uh, that delay line canceller. So in that case, delay line canceller, we are supposed to provide a reference signal. When we are providing the reference signal, okay, this one is about a reference signal, and then we have, because these are the receiving signal. Okay, so reference signal and then a delayed one. So whatever the we have the delayed one. So now reference signal plus a delayed signal. If we are subtracting both, so in that case we are getting exactly which one is our target. So target identification can be possible, or any information that doesn't have any shift in a frequency. Okay, shift in frequency, because the target is fixed now. There is no movement in a target, some stationary targets. If those targets are there, stationary targets are there. So in that particular case, for a given particular stationary target, we are getting the echo signal, because signals are transmitted. So we are getting the echo signal. So echo signal consists of what? A moving target as well as a stationary target. So out of this, so which one is our exactly a target to be identified? Okay, so now from this, now these are the peaks we are getting. Okay, now these are nothing but the peaks we are getting. So now from this, so which one is exactly our moving target? Okay, so now we can say that these are the a peaks. Okay, so likewise. So now which one? Because display devices will display the positive pulse as well as the negative pulse. But our aim is about to identify which positive pulse and which negative pulse is nothing but for the given moving target. Okay, so we are getting the on a display here with the whether it will be of what, a moving target of uh, okay, moving target of moving target. Okay, which pulse belongs to the moving target. So now we can consider that a different display devices. Okay, and from these different display devices we supposed to see that what will be the echo signal to be displayed for the given particular target. So exactly for, so we are getting, after using the delay cancel device, so we are getting only the peaks which belongs to the your target now. Now this one, okay, now this one. So here we are getting, okay, echoes we are receiving, or we are just displaying on the display devices that have a positive pulse as well as the a negative pulse. But some devices, some display devices are there, they are displaying only the, okay, These positive pulse and negative pulse are nothing but what? A bipolar device. Okay, these are nothing but a bipolar device. But some devices are there, they are not able to display the positive pulse as well as the negative pulse. So in that case, we supposed to use a unipolar devices, unipolar display devices. So in that case, it will detect, it will convert that, okay, that particular pulse, and then we are able to detect the only we are able to display on a unipolar display device. Okay, so how, what are the methods? Okay, so how to display the output? Okay, so now we will consider here one more diagrams to understand that what will be the block diagram of a single delay line canceller here. So in a single delay line canceller, we supposed to provide, okay, that is about the input to the delay line canceller, that is about a bipolar video. Okay, bipolar video. Okay, that is about a bipolar video we are providing. That is about the input now. Okay, this one is about the input bipolar video. Then we need to convert that analog to digital converter, A to D converter there. Then we use a delay. Okay, that delay is nothing but what? T is equal to what? 1 by Fp. Then we are going to subtract it. Okay, this one we are subtracting. This one is about original signal, and for the given original signal, delayed signal is to be subtracted. So we provide the input of the same. Okay, then after that we'll get some absolute value of your output here, and then we have a digital to analog converter, and that digital to analog converter is used to display a device. Okay, so we can say that we have the, this one is about your analog device. Okay, this one is about your analog device, and we are getting the data. Okay, so this one is useful for what? A unipolar digital video. Okay, this will be useful to convert that a unipolar digital video. Okay, so like that. So we can consider here a analog to digital converter, because our video is a bipolar one. So in that case, we need to display only the a positive strip, okay, instead of a negative. So our aim is about to identify where will be the a positive strip occurs there, that is to be displayed there. So in that case, subtraction of that particular echoes from a given particular strips here, okay, that is to be accomplished using a delay line canceller. Okay, so already we have discussed earlier the delay line canceller that is to be used, and then we use this block diagram, that is about a delay line canceller device, and that is used to display the that MTI output here. Okay, or we can say that here it is to be displayed on the analog device. Okay, okay, or you can say that analog device display, or we can write here a analog display. So, simple. This will be display here, or this can be used whatever the data we have, that given particular data is useful. This is nothing but what? A digital data. Okay, digital data for what? A MTI data. Okay, MTI output we have, and that data can be useful for the further processing. Okay, this one MTI data that is to be useful for the further processing. So we can consider here, okay, whatever the input we have. So in that case, at a receiver, okay, so output of the receiver is whichever output we are getting, that is to be digitized there. And to digitize that output, we need to use the a delay line canceller. This one is nothing but what? A delay line canceller. This block is about a delay line canceller we have. Okay. This one is about what we can say that a delay line canceller block. And this delay line canceller block is used to convert that output of the whatever the MTI radar is there, okay, so at a phase detector, so what we are getting, that is to be used to be displayed on the display device. Okay, otherwise what will happen? So we will get the output from the stationary pulses as well as the stationary target as well as the moving target. But our aim is about to detect the moving target. So in that case, we use a this delay line canceller block here. Now here is a bipolar video, because we have seen earlier that video consists of a positive sweeps or as well as a negative sweep there. Okay, and in that case we will use that positive and negative pulse, because we are getting the we are transmitting the train of a pulses. Okay, and at a echo there will be the change in the phase shift of the pulses. Okay, so in that case, instead of up here, so it will be goes down. So that in that case we are getting a pulse in a bipolar, that display will be display devices will display the bipolar video. Okay, these are about it. So according to that, what will be the changes in the that particular pulse? Okay, so phase change there. Okay, so according to that, we will get the a bipolar video. Okay, that is the bipolar pulses we are to be display on the display device. But our aim is about to display only the unipolar one. We are getting the bipolar video here, but we supposed to, okay, after here we are getting the bipolar video. We supposed to get only a unipolar one. So for that purpose, we use this particular kind of a component to display the device. So here delay we are using, okay, input bipolar video input we have, okay, that is about it. It consists of all, and then here we are using a delay here, and that delay is used to consider that what will be the radar output, okay, at the transmission there, because we are transmitting a pulse there, so that what will be the pulse repetition frequency, because we should know. So in that case, that pulse repetition frequency, that much is to be a delay here. Okay, and then we will get the output. Okay, that output will be subtracted. Okay, here that is about a subtraction, and that output subtracted output, we have it has the two sweeps there, and that two sweeps has nothing but what, here it is a bipolar video. Okay, this one is nothing but a bipolar one, and this one is used to this delay line canceller is used to subtract that whether that component or that pulses not belongs to the given radar, so that will be cancelled. Okay, it will be subtracted here, only the signal. Okay, bipolar video is there. Bipolar video means what? It's just like a video. Okay, so we say that earlier, we are able to display the, okay, so now out of this, these are nothing but a target. So now from this, which one is a, okay, which one is a moving target? Suppose this one is only the moving target, and these are nothing but a stationary target. So this stationary target is to be removed. Okay, so only we are expecting only this particular pulse. So for that purpose, we are using a delay line canceller here. So that is about a delay one, so that we are getting only the a bipolar video. Here we are getting only the a bipolar one. That digital video, it consists of what? A positive pulse as well as a negative. Now then, this one is about a bipolar video we are getting. Then this we need to convert it with respect to particular value, and that value, okay, that value is this in terms of, because this bipolar video is nothing but a digital data right now, because we are converting analog to digital now. This is nothing but a digital data, bipolar video, and that data is about a digital data. Here we are cancelling the echoes, which you that clutter echoes. Okay, so we are getting the echoes from the clutter, or we are getting the echoes from any stationary object. So that is to be cancelled here. Only the that signal, echo signal, we are getting from the moving target, that will be the out, that particular output is present here. Okay, so it will cancel all the clutter echo here. Okay, so we are getting only this particular bipolar digital data. Now then it has some particular absolute value in terms of a digital data. We need to convert that value for, okay, digital to analog there, so that we will get display on the analog display device, or we can get that particular digital data output here, okay, from this instead of, okay, sorry, here I supposed to consider that here we are getting the digital data, and that digital data, so from this digital data we can use for the further processing also, okay, this particular digital data. And then this one is about your analog display, we are getting the signal on the analog display. Now we say that there is a cancellation of what, a clutter echo, and that cancellation of a clutter echo, it has a both positive amplitude as well as the negative amplitude. Okay, so we can say that it has just like a positive amplitude, just like, so we can say that negative amplitude. This one is about positive amplitude, negative amplitude. But ultimately, our aim is about to get only the either both, but it is only the whichever the moving target, okay, amplitude, okay, moving target pulses we supposed to be detecting. Okay, so then we have the videos, okay, that is to be displayed. We can consider that a analog to digital or digital to, because we are just converting bipolar video. That bipolar video consists of both echoes from the clutter station, or we can say that echo from the stationary object as well as the echo from the what you can say, your moving target. Okay, it consists of both the data. Now that both the data is to be cancelled, okay, out of that echo from the clutter or echo from the stationary object is to be cancelled. So that's why this one is used. So here we have the a delay. We consider that that delay is to be used in the form of whatever the pulse we are transmitting, and that pulse transmission signal, pulse is transmitted, they have some pulse repetition frequency. So what will be the pulse repetition frequency of that pulses? So that will be the delay we supposed to add here, so that it will cancel the echoes from the stationary object there. Okay, so there are so display, we can say that analog display or digital display. Okay, so there are a lot of devices available, so they can display the unipolar video as well as the bipolar video. Okay, not necessary only we say that it will display only the unipolar one. Okay, a lot of displays available there, and that displays are used to detect the, or they are able to display the whichever the target there. Okay, moving to the another one. Okay, so we can proceed to another one. So MTI radar, what are the block diagram of a MTI radar? Okay, so this is about a block diagram of a MTI radar. Here we will proceed now. So we have seen earlier there is a mixer. Okay, there is a mixer, only single mixer is used. But in the case of MTI Doppler radar, MTI radar block here, earlier case we have seen only the heterodyne structure. Now here we are using a super heterodyne structure. Okay, so receiver will be what? A super heterodyne receiver. Now we consider that this one is about our antenna. Okay, that is useful for the transmitting and receiver one. A duplexer. This one is about a duplexer that is useful for the, I just this will be act as a switch. Okay, so switch means what? It will be on for a transmitting, off for the, okay, likewise. So on for on and off purpose there. Then we have a power amplifier, okay, and then we have, okay, so let's move this, okay, so MTI radar block diagram. Then we have a pulse modulator, okay, this one is about it, the pulse modulator, okay. So then this block is of act as a transmitter, okay. So for this particular block we providing the a local oscillator because that signal is to be amplified. Okay, so what signal is amplifying by this particular block here? Okay, this one is about for a power amplifier. We are providing the input here. Okay, so I'll just consider this way here. Okay, so we have a transmitter now. Then here is a mixer now because it is receiving the signal. So that's why we're supposed to use a mixer. Okay, then after that we have the IF block here. Okay, so IF amplifier. Okay, then we say that we have a phase detector. This one is about a phase detector now. Then after that output is to be given to delay line cancel. Okay, so this one delay line cancel. Now here for the mixer we supposed to use a stable oscillator. That's why the name is given as a stallo. Okay, so then again we consider that a mixer, and from this mixer we are transmitting the signal frequency. Okay, so that will be what f1 whatever the signal frequency we have, and here for this phase detector we are using another one that is called as a coho. Okay, so that is about a coherent signal generation. Okay, oscillator will be a coherent in nature. We are providing the input from the coherent here. So if you see the blocks, so we say that this one is about your stable oscillator. Okay, so stable oscillator, that frequency is about what we can say, it is about a f12. So this one is about a coho, so frequency will be a coho here. So output here we are getting at the mixer that consists of FL plus FC. Now this FL plus FC we are getting here. Okay, that will be FL plus FC. This one is it. FL plus FC is amplified now. Okay, then that will be transmitted. So that's why we have a duplexer there. Okay, we are using a power amplifier to get the high power signal. Okay, so that's why we need to use a high gain output. Okay, so high power, large signal that is to be transmitted. That's why we use a power amplifier. Pulse modulator, it is used to on and off whatever the pulse there. That's why we are using a pulse modulator. Then a duplexer, it is used as a switch for a transmitter. It just propagating the signal toward the antenna at the receiver, signal taken from the antenna to the mixer now. Okay, for a transmitter, taken signal taken from the power amplifier to the antenna at the receiver stage, when signal coming from the receiver that antenna, so that will be transmitted to the a mixer there. Okay, so now at this particular mixer block we use a stable oscillator now. Okay, Because stable oscillator means what? That signal is to be transmitted to the space toward the target that has a stable frequency. So that's why we use a stable oscillator, stallo. Okay, so that's stable oscillator, and one more oscillator we supposed to use here. That's the body, that coho here. Okay, so coho means nothing but what? A coherent oscillator. Okay, that is coho. Stallo is nothing but what? A stable one, and coho is nothing but a coherent oscillator. And that coho is used as a reference for the phase detector. Okay, we'll consider here. So stallo, that is the body stable oscillator. Then coho, signal we are mixing here. So mixer output is nothing but what? FL plus FC. Okay, so then we are transmitting FL plus FC here. Okay, and then at a receiver we have the a mixer here. So that mixer we is providing the, for a mixer we are providing the stable signal. So at this particular place, what signal we are getting? The signal we are getting that consists of what? FL plus FC plus or minus FD, because it is about a Doppler. FL plus FC, and then we are providing the FL. Okay, so we are providing the FL here. Okay, that is about the input. So if supposed to be there is a change in a phase occur, okay, so in that case, that phase in change means what? That is called as there will be a clutter. Okay, because we supposed to use a stable oscillator, and that signal is to be transmitting. So when we are receiving some signal, it has a small variation in the phase there. So in that case, we can say that it receiving it, we are getting the a some clutter signal. Okay, at this particular case. So, okay. So means mixer consists of what? FL plus FC plus or minus FD. After this output, we are getting here the signal. It consists of what? FC plus or minus FD. Okay, FC plus or minus FD, and it consists of information from the moving target as well as the information from the stationary object. That is nothing but a clutter. Echo from a target as well as the echo from the stationary object. That is about a FC plus or minus FDF. And then same input is to be providing to the IF amplifier. Okay, so we have we can say that IF amplifier amplify the signal for a given particular specific band of a frequency. If supposed to be noise are there, that is to be removed. Okay. Further, it will be propagate. Further, your signal is proceed toward the a phase detector. Okay. So now, if you consider here the phase detector, your input from the core, here signal here we are getting at this particular place, it is again a FC plus or minus FD, but here FC we are providing. So phase detector is act as a mixer. Okay, phase detector will be act as a mixer, so it will provide the output only the plus or minus FD. So we are getting the output at this particular place. After the phase detector there will be F plus or minus FD. Now this one is the input to be given to the delay line canceller. Then this input information plus or minus FD, that information consists of what? A echo. Okay, echo from, even echo from the stationary object. Okay, so that is to be removed. Okay, so now, or you can say that uncancelled clutter. Okay, so there will be a clutter somewhere. It is, you can say that it's about a cancelled clutter or uncancelled clutter. So our aim is about to remove that, whatever the clutter information is there, that is to be removed through this. Okay, so we are using a delay line canceller, and that delay line canceller then it will use to remove the uncancelled clutter there. Okay, so that clutter means what? That signal means having the same, near about same frequency. Okay, that is nothing but a clutter. Okay, because we say that we are operating, for example, we are operating in a VHF band of a frequency, for example. So nowadays there are a lot of application in the given VHF band, and then we are getting the information from those VHF band. If it is similar like frequencies there, so we are getting the same, we are detecting the signal from the other object. Okay, so because that is nothing but your moving target, so there will be the blind target detection occurs. Okay, target is not there, but we are detecting something, so that is nothing but a blind target detection. So for that purpose, so we should know that, so what will be the exact frequency of your device, or your range of the frequency, so that we can consider this particular component to be operating in the given particular range. Okay, and some signal they have, they doesn't have a Doppler shift present. Okay, we are detecting the signal. It's not only it is plus or minus FD. So there may be the clutter, even that clutter occur at a zero frequency also. Okay, so means we can say that FC plus or minus FD. So there will be the clutter. Okay, so that's why what we can say that there will be the clutter occurs at a zero frequency. So now that particular clutter is to be removed from the devices relay line canceller, or for any other measures to be taken to remove those particular clutter. So we should know that what will be the operating frequency for the radar as well as the operating frequency of all the components, we should know clearly. So in which band we are working there. Okay. So these are about what we can say a MTI radar there. So generally we are using high power amplifier devices. Power amplifier devices nothing but it will be consist of a klystron there, because it's providing the high power signal there, and that klystron, or even we can use the traveling wave tube amplifier, and that and that traveling tube amplifier, they are providing the high power signal. So that's why a power amplifier, it consists of a O type tube or a M type tube. Okay, means klystron, or even crossfield devices, that is M type tube. Okay, so or we can say that linear beam tube. Okay, so likewise, so we can use any other devices that will amplify the a signal. Okay, but if we are using a solid state devices, so we are not able to get that much of a power there. Okay, so solid state devices are also available, because solid state devices are more stable as compared to the klystron and traveling wave tube amplifier. Okay, so we can use this also. Okay, we can use a solid state devices as a amplifier, because those are stable, but output as compared to the tube is less. Okay, so power amplification, so amplification of your signal, so that will be low as compared to the klystron amplifier. So that's why for stable operation or for high power amplification, so for what particular purpose we require in those devices, so according to that we have to use it. Okay, so that's all about what you can say that a MTI radar there. So now we will proceed further for to understand that what will be the a MTI delay line canceller. So generally MTI delay line canceller, it is just like used to reject the stationary clutter. Okay, because we are getting the echo from the stationary object. So this device is used to remove that whatever the clutter from the stationary object that is to be removed. So for that purpose, we should know that what will be the frequency response of your device, as well as the frequency response of this delay line canceller. So we will see that delay line canceller, and what will be the frequency response of a delay line canceller there. Okay, so with this we stop here. So thank you all of you.